All right, so I was doing this example in class, and basically I have the simulation built three different ways in XCos over here and Simulink over here. And so the open loop system is this 4 over s squared, and basically I have a PID controller here where the proportional gain is 10 and the derivative gain is 6. Now, if you close the loop on that, you're gonna basically this is gonna be a transfer function that's 10 plus 6 kp, and 10 times 4 is 40, and 6 times 4 is 24. So if you close this loop, you get this transfer function here. So this is your closed loop transfer function. So if you simulate both of these systems, you should get exactly the same thing. What I noticed though is that if you open up the PID block, the way they implement the derivative gain is they have n over 1 plus n over s. And basically what that means is that they're taking their error signal, running it through a derivative filter, which is basically a derivative plus a first order filter, and then multiplying that by a gain. And so this PID block is basically this. This 100 is trivial. You can make this 100 as big as you want. Well, I mean, obviously you're going to have integration tolerances, but 100 seemed to work pretty well. So anyway, so here you can see my gain of 10 and my proportional gain of 10 and my derivative gain is 6. And so if I put this all together, these should all be the same. So if I simulate this in Simulink and I open up scope 0, here's scope 0, so that's the one with the PID broken up. If I open up scope 1, here is the same, exactly the same with the PID block using the internal PID block. And then here's scope 2, again 0 to 3 seconds, and here's all that well and good. So Simulink is capable of simulating the entire system the exact same way. And so what I did was I built the exact same transfer functions in XCos. And so here's the same system. Here's negative feedback. Here's the 4 over s squared. Here's the PID block, proportional gain 10, derivative gain 6. And then here's the same system broken up just like I did here in Simulink with the derivative filter here, and then the gain is 6. And then down here, here's the closed loop system. Now what's wild is that if you run this, you get that the scope 0, which is the top one here, is exactly what we should expect, a little bit of overshoot. The scope 2, which is the closed loop transfer function, same thing, is also the same. And these might actually be slightly different, and that could easily be because of the derivative filter here. But here's scope 1 using the PID block, and it's completely different. And so I think that the PID block is broken in XCos, and therefore I don't recommend you use it. If you have any questions, post in the comments. Have a good day.